What's next for IT? In today's economy, technology touches every aspect of the day-to-day operations of business. There has never been more pressure on IT to deliver for our organizations. So what can we expect over the next decade? We need to think differently about how we approach our work to continue to thrive into the future. This requires all of us to be intentional in how we look at our role going forward. Smart IT is an approach to getting the important things done by transforming the way we think, work, and lead. And now, let's disrupt the status quo, simplify the complex, and reduce risk the smart IT way. All right, everybody, welcome to another episode of the Smart IT Podcast. And today I'm welcoming Chip to the show. Hey, Chip, how's it going?
Very good. Nice. Thank you for having me.
Well, it's good, man. We haven't seen each other in a couple of years. It's been, I think we met out on the East Coast somewhere at a fair conference years ago. So it's always interesting to meet new and interesting people, connect, and then years later, look them up and then just catch up and chat.
Oh, thank you. Your memory's good. I'm not sure I can remember 3 years ago. I'm having trouble remembering last week. So.
I know. Actually, there's a guy who came out with a concept called the second brain. And he teaches people how to have a structured way of capturing their thoughts, interesting things they see online, quotes, links, and it's an interesting structure he has to that. So he said, like, the brain is designed for more creative things than actually storing data. So you're not alone there.
All right, very good.
So we have a lot of cool things to talk about, really, but obviously here on the Smart IT podcast, we talk about IT leaders and the teams they lead, going out there and designing, building, operating, and defending our digital infrastructure, right? So the powerhouse of the modern global economy, a lot of technology out there behind the scenes, making everything cool and work well. So we got a lot of things in the news today and last week and weeks before that and last couple of months and years. And it seemed like it's a never ending stream of headlines for the wrong reasons, right? There's systems down. You get these images of hospitals down, people backed up at airlines. And I'm always interested to kind of weed through the noise. And then at some point later, it could take days, weeks, and sometimes months to get down to root cause analysis. But always kind of interesting to read through what the final kind of analysis of what happened. Why did the system go down? Was it a natural occurrence? Was it a cyber attack? Was it a glitch? So it's always interesting. So I know you've been in the field quite a while here, and just let's start with getting some initial thoughts. So like when you keep turning on the TV or get your phone ringing and hear about these headlines and have all these business disruptions, what comes into your mind?
I think most of all, I think we've created an environment where, for both good and bad, right? We've created this massively adaptable, rapid environment that we all know, which is you go on your phone and you want a new app and you hit a button and within 30 seconds, you have a new app on you, right? Where we used to have data rooms that are all of our buildings were this raised floor. None of us have that anymore, right? We can get new capability rapidly. It all is coming at our fingertips. But there's a risk to all that, right? And we are starting to see a lot of that risk, both from the cybersecurity perspective and now from, I'm going to call it the fragility perspective, right? Which is that we no longer really control a lot of what goes on, right? It's this ecosystem of third-party providers, of applications that is now this totally integrated world that moves dramatically fast. But when things go bad or attackers want to make things go bad, it can go bad really fast and really big, right? I think that's what we're seeing. And it's the outcome of the last 5 years of migration to this new ecosystem that we're now starting to see the pains of that.
Yes, interesting, because you keep seeing a whole bunch of things around microservices. The old days would be you would package a whole bunch of features up and maybe get it in 2-3 years. Now microservices, I want that new little thing here that's different as a new feature, and they just turn it on in the background. And you're like, whoa, what's this?
Right.
And then, but they're trying to meet this demand, right? The customer does, I want more, I want this, I want it faster, like you said.
Yes. And it's what drives the revenue for most companies, right? Whether you're a financial firm that's rolling out a new feature in hours, or whether it's the newest game on your phone, or whether you're, you know, an airline who's offering, new uh, capabilities to make a quick reservation. All of those things, they are incredibly quick in development, but they're also, coming with a price. And we're just at the very, very tip of that. We're I've written some papers about this lately, which is that what most people, as we move into artificial intelligence, most people are thinking about. They're probably thinking about like the thing telling you to really bad data or giving you bad stuff. To me, the bigger impact is speed. If you think we do things fast today, in a year from now, just a year from now, double that speed. Right now, if you think about building a software program, let's just say it takes you 2 months to build a capability. It's going to take you 6 hours.
Yeah, wow. Yeah.
Right. And it's good when you're done in 6 hours, you're going to want to roll it out to your clients in a day. But taking the CrowdStrike story that everybody's talking about, now you can see what can go wrong.
Yeah. And it's interesting that you mentioned CrowdStrike. I'm always taken aback a little bit because I'm not sure a lot of people, or even IT leaders, kind of realize how much, you mentioned the third parties have an influence and control directly in their infrastructure. Because in theory, change advisory boards, right? It's the CAB. No
Right.
change is allowed until IT analyzes it, determines what the impact could be. So before you upgrade a server or a storage array, or you change code on an application that you're developing, there's all these considerations. And then maybe a change advisory board, if it's officially set up in some of the larger organizations, they say, okay, we've cleared that. We looked at what you want to change. Now go ahead and do it. Well, in the case of CrowdStrike, it's different, right? It's third party and they're pushing it, this update
Right.
outside the process.
That world has, what we've all grown up with the change control boards and the documenting that world, I think, had left the station, right? As you were pointing out, so much of what we're doing now just comes. We all, your community all knows about the first Tuesday of every month, right?
Yeah.
Microsoft pushes huge numbers of updates out, so and we all have to get them. And of course, I live in the cybersecurity world, the advanced technology world. That's really important because as soon as they push it, right, then the attackers go after those people who've not updated their systems. So time is important. The time of pushing isn't just to get new features; it's for security, which is the as we found out today when they reported it, the file was exactly that. It was a file to address a threat issue with CrowdStrike. That it is important that they get those out in a hurry, but we also saw the downside.
That's interesting about that because it's slightly different, right? Because in the Microsoft case, IT still controls the button, right? Either they're gonna before the
I
upgrade.
would guess most people don't have a button. Those push, and a lot of folks go to automatic Microsoft update. My machine, I don't know about you, but most of the machines I know, come Tuesday afternoon or Wednesday morning, you're getting an update, right?
But it's configurable, so you can
it is configurable.
So you can turn it off. So
Yes.
some of these SaaS applications, there's no button to turn it off.
That's
and really
true.
what IT wants to be able to do is say, hey, let's get the new update in. Let's try it out on a subsection of our machines, our assets, make sure nothing breaks, and then let it loose, scale across our infrastructure. So I think probably what you're going to see with some of these SaaS applications is the ability in the future to control and say, it may slow us down, but we're going to put it back onto you, internal IT, to push the button and say it's good to actually deploy it across the board.
I think that is a path. I tend to live in the advanced technology. I think we need to move in a different direction. I think we need to move in a resiliency direction. In other words, okay, take the CrowdStrike situation or move it last year or others, right? We need to move in a situation where these things will happen, but the impact it has on our business is minimized, right? The fact that this one application, CrowdStrike, brought down, airline flights, right? That to me is the bigger question, which is, well, okay, let's say instead of it was a 3-day impact, it was a 20-minute impact, right? Then it wouldn't have been the news that it is everywhere, right? So that's looking at the problem a little differently. That's looking at how do I actually respond to things, and that goes to the cybersecurity world too. I talk a lot about it. I think the idea of trying to stop cyber attacks on our machines is that we're chasing ghosts, right? Because the scale of the problem is so big and there's so many things going on that what we ought to start looking at is, okay, congratulations, you landed on my machine, but you got nothing out of it. Or I recovered in half an hour. My entire operation didn't shut down. So looking at the more resilient side of things, both whether it be on purpose or accidental, I think is something that organizations need to start looking at.
Well, it's an interesting question here because not all assets are equal, correct? So if you have a PC running Windows powering the kiosk, doesn't need to update as fast as maybe a front-end server. So in our case, where IT is doing kind of a broad brush, right? And even the operating system, right? Microsoft said, you always get these updates. Some machines at the front desk, for the doctor, some are running machines, but some aren't as critical. So there's no differentiation being made. So it's almost an attack, threat, defense mindset, which takes away the organization ability to see what the risk appetite is. They may say, hey, you know what? For certain systems, this 20%, I need to update immediately. Maybe this other 40%, less risky, I'll do it in 4 hours. The rest I can do within 1 day, and that fits my risk appetite, which puts the responsibility back to the business and internal organization as opposed to third party. I think sometimes we're like offloading way, way too much. And each individual and each organization could say, you know what, let me choose for myself what my level of risk is. Because like we said, that endpoint is only one control, right? You may have 70 other controls. So my environment, my CISOs are like, yeah, you may or may not land on my endpoint. I have other protections in front of it. I got mitigating controls. It may be firewall zoned out. So there are other ways that the one vendor wouldn't know about. So they may have an initiative or impetus to push it out fast, but my environment may not. So talk about let the IT and the business themselves make that choice how fast they want to push something out.
Yeah, and I think that's exactly the thing, which is about the resilience of the business, not just the resilience of IT, but the resilience of the business. Okay, here are the things that I cannot lose, right? And then that becomes, your risk appetite for those things is very, very low. But so you put not only controls, but the way you address that and do things like your third party updates, et cetera. Those critical business functions become addressed. But we don't really, most companies look at IT across the board. It's like big one flat thing to look at, as opposed to turning the question upside down and saying, what are the most critical things to my business? If I fly an airline, what's most critical? I need to get airplanes off the ground, right? Yeah. What are all things that make that, right? Starting to look at things like that and looking at the problem differently.
And it's interesting, it's cool, because we used to do classification of assets all the time and matching to the process, matching to the service. So it's almost so ubiquitous now. Like, take like a casino resort, right? I mean, we need the machines and servers up to like do badge access, right? Reservations, order food in the background, video surveillance. So it's not like, oh my God, I'm starting to classify all these assets as critical and important. And you're going to notice if any one of those things are down. Your customer's like, hey, I can't open the door, or you can't take my order. You can't take my credit card transaction. So how do you think about that when you think about almost everything kind of looks like critical and important?
Yep. Now I will take you to another path here, which is something I've been working on for a while. And this is trying to mitigate cross-customer impacts. And what I mean by that is CrowdStrike's a good example, right? One file brought down all these massive things. Or take MoveIt last year, which is MoveIt get breached, and all these organizations. I think we need to get to the point, and there are technological approaches to this, where I can use platforms, but I'm not dependent on that platform security, for example, right? I can use your data storage. I can use, a cloud, but I control, for example, my data. You don't. The platform does not, right? Or even when it comes to software updates and things of that sort, as you were pointing out, that there is a local check before a final check, right? That's looking at trying to minimize any of these situations, whether it be the we all dealing with the snowflake issue. Now we're dealing, those are platforms. When the platform gets compromised, thousands of companies are impacted. We need to come up with a way that stops. Okay. That somebody may attack my instance or my data on a platform, but that's all they got. It's me. They didn't get 500 other companies, right? That's looking at the problem differently. We do a lot of work on whether it comes encryption of data, tokenization of database, things like that you can start putting into place that gives you that type of minimizes your dependence on these third parties.
I kind of remind you of reducing redundancy on like single telco providers, right? Mm-hmm. Like, oh my God, we just had out here in Texas a Spectrum outage, followed a couple of days later by a Google Fiber outage. So for some people, when they were down, they literally were down. So then we talked about how many links are we talking about to the data? Is it the same carrier, multiple carriers? Is it extra bandwidth? And then you get in the cloud, are you in the same availability zone? So this kind of get into that enterprise architecture conversation of how we're designing our systems, right?
Yeah, and I'm a big independent systems guy. What I mean by that is I'm a big person who believes, I do not believe the big system's a good answer, right? I'm more of the more I can break things into small components so that if any one component fails, it does not cause failure across other parts. All the way down to, and I've written a lot of papers on this, data, all the way down to every single file can be secured itself independently of wherever it goes or however it goes, right? So that's the lowest level you can get to, which is, I don't care if this server went down, or I don't care if I lost, I just moved to another path. I moved to a different processing. We talk about ransomware. To me, the biggest mitigating risk to ransomware is recovery, not stopping man. It's recovery. If I can recover in 2 hours, I don't care, right?
Like infrastructure is a dime a dozen, right? We can code infrastructure as code. We can spin up service everywhere. But you're right. If we have access to the data, spin it up somewhere else, no big deal. We shouldn't be relying on this one system went down. What's the recovery time? Oh, why is that? It kind of reminds me.
Yeah. Think of the CrowdStrike, right? This is one application, right, with one tiny little file that caused this massive impact. That's the opposite of what I'm talking about, which is getting to the point of independence of services and data.
It's almost like the load balancer, right? You got a couple load balancers in the front end of your e-commerce site. You have 200 systems behind it. That's done. The code has been spewed out automatically. And if you want to test something, take 2 of those nodes out, test it, look good, spin it out, and then re-image the other systems and configure the exact same way automatically, right? But the service stays up and running. So I always say you want to reboot systems, individual nodes, but not the system itself. If the system itself gets rebooted, you're going to notice something.
Yeah, if it would be kind of that's a good analogy, which is almost getting to the application and data load balancing, which is I don't care if I'm on AWS, I don't care if I'm on Azure. I can run anything, anywhere, anytime. That would be the the holy grail if we could do that. Yeah. That'll take some time, but it would be a good place to get to.
Yeah, you can almost think about AI generated systems saying, what's the cheapest place to put my storage for the next 3 minutes or 4 minutes or my compute?
Absolutely. I think without a doubt, we're going to get to that point, right? Which is I can use a system to say, where should I actually run this application from my phone to a cloud capability that I could figure that out. And oh, by the way, if I don't have access to a point, by the way, and if you think about it, that solves lots of problems. Everything from disconnected people out in places with limited bandwidth to military application, everything, which is the ability to quickly identify and then operate applications, and most importantly, data, right, is the key. And the key to that is that the data is independent of the systems and networks and applications it runs on.
Yeah, I think I read that article that you mentioned because it was fascinating, right? Because we're spending so much time trying to wrap the control around the machine, the VM, the storage array. But you talk about who cares about that? Let's talk about the data itself. So somebody grab it, take it somewhere else and try to read it. They're like, I can't read it. What is this? Right. It's useless to me.
And the funny part about it is we haven't gotten that place. Well, actually, technically, we do know how to do that. And we're not there. We're working on it. Lots of folks working on it. But that is that is I think a critical capability for us to get to the point where the data is independent of where it is. The other side of that is that, as we were talking about before, as we move to AI, that is essential, because otherwise AI engines are going to capture data no matter where it goes, right?
Oh, yeah.
So for you to protect for example, to protect a drive or a file location from AI, but as soon as somebody emails that same file to somebody else, it's gone, right?
Yep.
So we can't rely on the IT infrastructure to protect the data. The data has to be protected by itself.
You have to free itself. And then you even need logic in the code itself, because AI can move itself, right?
Mm-hmm.
Maybe it's the mobile containers. Maybe it's running on one system today, another cloud provider tomorrow, then private cloud, then third party, but it's always had access to the network somewhere, right? So bigger network pipes across the board, always on connectivity, and it kind of frees up a lot of constraints right now. Okay. I was thinking about one of the pain points people have is their smartphone, right? If they break it, the amount of time it takes you to get that phone back to the exact working condition, even if you're backing it out, it's like a hassle. It's like, man.
Yes.
It's like,
yeah, I have kind of two views of that. Number one, you're exactly right on one hand. On the other hand, it's a lot better now than it was 5-6 years ago.
That's true.
Like, used to be, you go if your phone got broke, it'd take you like days. Now you go in and you hit a button and everything's already in Apple's cloud or Google's cloud, and down come all your pictures and come down. There you go. But it's still a hassle, right?
Yeah, I was thinking about that. Not backing up. You're right. A couple of years ago, you didn't back up the contacts, and nobody remembers any phone numbers. So you get your brand new phone. There's no backup of contact. I have no idea how to call this person or what their email was. That is kind of interesting. And I can also think about, we talk about moving the data, right? And moving the code itself. So we get to like self-driving cars. You can imagine a world where there's multiple connectivity spots on the car itself with multiple nodes. I'm running one active node, and then maybe there's another node at capacity and compute power on there to actually do something different and update it while you're still driving. I can see some very interesting scenarios like that coming out in the future.
Oh, absolutely. But it also gets back to the point we started with, which is we're getting to the point of all the AI capabilities that I find most fascinating. The auto generation of code is the one that I find fascinating. Why did Microsoft buy GitHub, right? Because they wanted the code, right? And they built Copilot, right? And so the ability to rapidly create code with almost no human involved, right? We're getting to the point we're going to auto-generate code on the fly. And so you were talking about being able to pull up new capabilities. I would not be surprised if within not too many, we're actually going to take input, create new code, and update features on the fly. Right?
Oh, that'd be wild. And then it tells you about go ahead, yeah.
Until you have a CrowdStrike situation and a bunch of things. Yeah, right.
Well, you know what? Then AI can get smart enough and say, this is the third time there was a glitch. So I'm going to spin up some other infrastructure somewhere else, run it, test the new code, test it, do some synthetic testing, make sure everything works well, then load it over. It would never actually switch out production until it did a check, and they could do it at speed. right? You wouldn't
Right.
notice it was doing it in the background.
You would. Now, by the way, of course, I live in the cybersecurity world. The attackers are going to be doing the same thing, right?
Yeah.
One of probably one of the things that I think is important to you, where you talk about speed, when it comes to cyber world, you can't get an update for a security update and wait 2 weeks. That doesn't work, right? Because we know the attackers, when Microsoft pushes Tuesday, they call it Push Tuesday, they call it Attack Wednesday, right? That's because they're looking for people who've not made that update. They've not made the security update, because that becomes a vulnerability that they can go after. And that happens to all the products, right? When a product pushes a security update, the attackers have automated systems looking for those people who have not done the update. In the world we were just talking about, that same process is going to happen, but it's going to happen at massive speed, right? So which gets back to the resiliency issue that we're talking about. We have to make it so that, okay, even if that does happen, your business doesn't shut down for 2 days.
I can also see, right, the AI on the defense side also have multiple different ways to block that path, right?
Yes.
So let's say I'm going to patch. It's going to take me an hour instead of 10 minutes, but I'm good because somebody else just got hit. It informed my perimeter firewall that's on this container, which also got updated to have some mechanism to do blocking, and have some other different ways on the host to obfuscate the ability to actually exfiltrate data or something else, and then go ahead and patch. Because if you got like 60, 70 controls, right? Because cause people always ask me, like, hey, how can one click all of a sudden a big organization spending all this money on security get hacked? When just one, don't you guys have all these controls? So then you start to talk about efficacy of the other controls and how well is it working against the actual adversary with hands on keyboard. So it'd be interesting just to spin up a blue team AI and a red team AI and like
that would be good. Yeah.
Sit back and see what it does there. And say, you know what? I'm going to encrypt the data, since like my controls can't stop you from getting on the box. And before you get the network's going to allow you to exfiltrate, I obfuscated the data and encrypted it. So when you copy it off, you get it, and it's like, I can't read it. It's no good. And it's like,
yeah, exactly.
That's going to be a fascinating world.
It is.
But we got to be able to read it, because when we saw the Matrix, right? The guy was reading all these strings.
That's right.
It said it's too complicated to actually keep up with it. So we can't enjoy the show. It's going to be like, man, what's going on in the background? The true black box.
Yeah.
The other thing that's interesting. So we're talking about the availability of our systems, right? Resiliency, and always the need to update, right? We need to update code. I was thinking about this other day, right? In theory, how about an update day? So you get up and your smartphones prompt you for an update. Smartphone prompting you, your pacemaker prompting you, your clock, your refrigerator, your car, your storage array. Like, cause you got to upgrade code for interoperability reasons, adding new features, fixing bugs, security vulnerabilities being fixed. There's a lot of reason why code has to be updated. But the fact that code is everywhere, right? I mean, literally everywhere. It's interesting. So I got a new little exercise I ask people now. So Chip, if you're in the car right now with 3 other people and your phone's up there doing the navigation and you get a prompt for updates, do you update immediately or do you wait?
I'm probably going to wait. Well, wait, where am I going?
You're driving and it's navigating.
I know, but am I going to the restaurant to get some dinner, or am I going to the hospital because one of the 3 people needs to get to the emergency room? If there's somebody going to the emergency room, I'm not updating the phone. I might update the phone. If we don't make it to Texas Roadhouse, we'll go to McDonald's. I don't go to McDonald's, but we go to some other place, right? So that's back to your risk situation.
Right.
When I update the phone, I might if it's not that important, or I think I know where I'm going. Because I'm one of those silly people who still think I know where I'm going most of the time.
In that case, with the other 3 people, you just had one of the person in the back push the button. Let it update. 20 minutes later, say, your phone still work? And do a little check. Contact still there. Make one phone call, browse. Okay, next person in the back. You go ahead and push the button. So by the time you get to the destination, all 3 of you down, and you stop driving, get out, and then you can hit the button, the 4th person. So by the time you get in to have dinner with your company, you've all updated, but you did a little control there.
There
one
you
at a
go.
time.
There you go. You were being resilient, right?
Yeah,
You were making sure that we operationally were able to get to the restaurants. That
yeah,
was a good thinking. There you go.
yeah. If the update was bad, it's just one person out of luck. But hey,
Exactly.
we can still stream music, still do the navigation, check the weather, check the sports. So it's
That's
kind of
right.
this interesting ways of thinking about this.
So most people don't realize because I think I've read that at least on iPhone updates on average 17 applications a week on your
Oof.
phone.
And
You
that's
probably
something.
aren't aware of that, but that's
Oh
what's
yeah,
going on,
yeah. Auto
right?
update.
So
Yeah.
that gives you an idea that and I think that number is probably low, but it depends on how many applications you have on your phone. But that gives you an idea. Things are getting updated all the time, right? And you just don't know about it.
So I had a kind of a horror story a couple of years ago. One of my clients had a next gen advanced firewall internal, and they did an operating system upgrade. So it came back up, looked like everything was working until one critical business app stopped working. They said, well, what's going on here? So it turned out it's doing application inspection,
Mm-hmm.
and the update broke the parser or the ability for the traffic inspector to identify the business critical app properly. So it misidentified the wrong ports. So it blocked the business traffic.
Mm-hmm.
So after that, it introduced a whole discussion around, we now need an entire lab on the side to do firewall updates. And then that whole thing of generating traffic and passing it. But it was like, my God, this firewall is in front of a lot of critical traffic. And then how do you make sure before you do the firewall update? Same with load balancer updates or wireless LAN controllers. I mean, if you're in a hospital and you want to upgrade your wireless LAN controller, that's a lot of access points to have to reboot in the series. And it's like, dude, I can barely get a change window in here. When do I update this stuff? And then, or maybe this local switch in the closet and plugged into it is a physical camera, right? So physical, at the guards are looking at cameras for actual intruders. If I reboot that switch, that particular coverage for that camera area. So now all of a sudden, IT is involved like, well, dude, when do I find a window to change anything, right? Firewalls, routers, load balancers, code. I mean, would you want to be a CIO today, Chip, and have all these kind of decisions going
No,
across your desk?
I don't know. Yeah, I don't think so. I'm past that. I think I think it is. I think it's a really tough job to do right now, and particularly because you have such little control. Right back to we were talking about third parties. We were talking about as you pointed about the interconnections of all the devices. And now nobody's even in the building anymore. Everybody's working from their houses. We have no idea what they're, it's as it's not only is it difficult just to keep the updates, but the attack surface by the bad guys is massive, right? So it's a challenge, that's for sure.
And I know it's a lot of challenge around the governance side of the house, at least to keep the business on top of what's going on. Because when the data was in your own data center was one thing, and then you have all these controls in place. CISOs felt pretty good. They knew what was under their house. Then you might go to these workloads to the cloud. You found that there was a lag between the security vendors coming up with tooling for it, and the ability for CISOs and CIOs to actually monitor that workload in the cloud. So if you had a breach and they're like, hey, who ran the governance for this cloud? And it's like, I don't know. CISO like, hey, my tools are in the data center.
Right.
And then years later, you catch up and get more cloud. And then you go out to these. Okay, go ahead.
Well, I was going to say, I would just take the Bank of America Infosys breach last year. That wasn't third party. That was fourth party, right? Which is that a vendor to a Bank of America, a vendor to the vendor, right, was the one who got breached. And how is the CIO or CISO at the top level to ever know that, right? Health records is probably the worst. We spread health records all over the place for places, and then something bad happens. We all know about Change Healthcare. Something bad happens, and nobody knows where any of the data is anymore, right? Because I gave it to this provider, who gave it to that provider, who gave it to this provider, all the way down to the guy who's running the blood test, who's 6 layers down, down the line. So I think the problem with this is the lack of understanding of where the data is to begin with, is a major challenge right now.
And it's kind of ironic because it's like the actual engine, right? The availability of the data allows these processes to work, make you digitize all these workflows, right? So in the future, you're not carrying around or having to fill out all this information because they scanned you, or it's biometric identification. So that's convenient for me. I got to scan it and do something special. And I got to let the data transfer from one doctor to a specialist to save you time from having to do all this phone call or going to the drugstore. So it's convenient. So I think the main thing, and we start talking about economics here, is like, as long as there's more benefits than actual losses, we're in a good shape, right? It's like banks have fraud every year, right? And they spend money on fraud detection and prevention, but they come out ahead at the end of the day. So let's talk about the economics of this, these benefits we get, trade-offs, and then what the losses look like.
I don't feel. I wrote a paper several years ago, got a little bit of notice. It was called "Why the Next Cyber Czar Should Be an Economist." Right, and the whole point was what you just talked about. In the end, this is an economic battle, right? Which is right now the attacker. It costs them very little, and the return is very great. For us defending, the cost is very high, and as we've seen lately, the success rate is not very high. So the economics are way out of balance, right? Attackers are getting a lot and they're making a lot. It doesn't cost them much and there's not much risk. We are spending huge amounts of money trying to protect everything, and we're not even being successful with that. We have to change the economics. And now I'm going to take that to what the point you made, which is then we have to tie in the economics of what is the value to my business of this capability versus what is the risk for me not having it or causing me. And as we get into the AI world where we can rapidly create something in a matter of hours, as we were talking about before, you're going to have to make a business decision. Do I want it or do I not? And I think that's, I think we need, it's funny, we keep talking about CISOs talking to the board. I think CISOs need to be more economically understanding of what's going on as well. It goes both ways. You say, well, the CISO got to talk to the board's got to talk to the CISO. Right? Board's got to say, these are my top 5 priorities from a business perspective. You make sure those things work, right?
Right. And you do the technology mappings and all the details because you're the subject matter expert. Yeah. You should come back and have an intelligent path like, we can go this way, this way, this way. Here's the level of effort. Here are my dependency. By the way, doesn't cost much money, but you have some other projects that are not in my purview that I'm waiting on this critical path. Map that out and make it consumable, right? Because sometimes the remediation is kind of weird, or what we got to do is not really clear to a business person, like X amount of dollars, how often, and you risk actually doing something like that.
Yeah, and that was, you mentioned we met at a FAIR conference. That's a big part of the FAIR thought process, which is, okay, it's going to cost me $1 million, but it's going to protect me from, $1 billion of risk. Okay, that's a decision I'm willing to make. Or it's going to cost me, $50,000, but the capability I'm getting is going to generate, 500 million in revenue. Okay, I'll take it. So we need the economic discussions of both cyber and soon AI and others. We need a much better economic understanding of these things than we currently.
Yeah, and definitely help with the CISO, this whole burnout mentality, or this feeling that they're by themselves. They understand the numbers.
The CISO, as I was mentioning before, I think the CISO is in an unwinnable position right now because I've used the term chasing ghosts, which is, every day. I mean, every day you turn on your computer and you've got, when CISA came out with their known exploited list, known and exploited vulnerability list, they originally had 33 on the list. And we all saw it and said, I can handle that. We're well over thousands now, I think 1,100 or more. And like new ones come out every day, right? Just chasing down. First, you have to figure out, is that even in my environment? Does that application environment? Then if it is, I mean, the pace of activity is mind-boggling, and I don't know how any CISO keeps up with it. So,
well, it's kind of fun. We go out to FAIR and the entire the rigor we put into it, like this threat event frequency, right? Like how often is that particular attacker coming after my type of organization? What the type of telemetry do I have on my security controls that give me some type of idea what that frequency might look like. What are the other compensating controls in play? We technically know what this looked like. Like, now I got this segmented, that environment's not available. I'm using my wireless encryption differently. I'm doing my remote differently. They have a good idea, but they need to have that rigor. And what I love about FAIR, right? It forces the technical team put rigor behind it. So when you look at those risk scenarios, those loss scenarios, it's tied to what the business just told you, like what you're talking about before, those 5 critical business initiatives or priorities. Map that down to some scenarios and find out. So you're not patching everything. You got some known vulnerability that might still be available, but it's a very, very low frequency. And then you took care of some mitigation on the background, on the back bay with the insurance, quick response time. We can recover very quickly. It's inside of our SLAs. So there's a lot of things we can do. Like you said, we understand the economics of it, understand the business, and just prioritize, right? If you can do 4 things a day, what can you do? And don't stress out because you can't do the other 10 because nobody can, right? I mean, literally nobody can. So man, this time is just flying here, man. So I wanted to talk, I always like this metaphor here and say, like, bad guys come after you because they follow the money or the ability to make money. So, it's always amazing when you try to compare this to like the real world. Like we think about banks and how much value is digitized. But think about it. There are still people who out and do bank robberies. Think about how hard it is to do bank robberies. We say, hey, be a hacker, steal it digitally, but people still get in trucks and vans, be mad, and physically risk their own lives to go after money. It's like, my God, the things humans will do to actually go and
Yeah, that does not seem like a good trade-off to me.
I'm like, why are you doing that? So maybe they think the cyber side of the house is too crowded, so we're going to stick with this. So we know it. We know it's $10,000 in that ATM machine or the cashier. So it's always an interesting scenario there. So I always tell people, right, the day that you don't need CISOs and cyber is the same day you don't need police, right? Because no one's going to do crime, right? Or you don't need the army because of the military. No one in the military and the police would ever say they're going anywhere in the next 100 years, right?
No, I don't think we're going anywhere.
Yeah. So I think we just need to get CISOs and others kind of in a more steady state. So then it's like it's firefighting all the time. And realize most of our systems are up most times. Most software updates go without a problem. We're reaping the benefits of a lot of digital capabilities every single day. So, I mean, it's a lot of progress. It's a lot of good things happening. And the good thing is every time the attacker changes their tactics, they change it for a reason. IT and security teams are doing things that's forcing them to make a change. So that's how you know your efforts are making a difference, right? And at the end of the day, the business is going to say, hey, you did as good as you can, this level of effort, don't need to spend more, you're doing a good job. So I think we need to keep that perspective sometimes. Is there anything you want to leave us with? We know we talked about some economics.
No, I really enjoyed the conversation. And like I said, we're at an interesting time right now. It seems like every week there's a new big story. I'm hoping this calms down here soon and that we can get through a week without another massive data breach or system loss or something. Just nice, quiet summer week would be very nice, actually.
It definitely would be. Well, it's been a fantastic discussion, Chip, man. I appreciate your time today.
All right. Thank you.
All right. We're going to close out now. This has been another episode of the Smart IT. Until next time, take care. Thanks for joining another episode of the Smart IT Podcast, where we explore what's next for IT and disrupt the status quo, simplify the complex, and reduce risk together. If you like what you hear, please like, subscribe, and leave your comments. And for more Smart IT wisdom, check out my website at williamreed.info.